In this next section, I'd like to take a look at a more complicated process of NAT application called Dynamic Port Address Translation, or PAT, or Dynamic NAT with Overload. There's several words that describe this. Let's look at what it's doing, and then you can call it whatever you want to call it. You can call it PAT, you can call it NAT with Overload, you can call it Dynamic NAT, Dynamic PAT, all kinds of stuff. So Dynamic PAT works like this. Imagine your home network. In your home network, you have some type of connection to the internet, whether that be through a cable modem, a DSL modem, maybe satellite, hopefully not dial-up, but we have some connection to the internet. If you're a business, you might even have a fiber optic connection to the internet. However, in this case, I'm talking about very small networks, where we only have one single IP address to the public internet. Much like the last example I used for static NAT, where we only had one IP address to get out to the public internet, and we were able to manipulate the ports to allow that to work. Well, now here, imagine if I have two PCs on my local network, 10.0.0.10 and 10.0.0.20, and they both want to surf out to the internet at the same exact time. As a matter of fact, not only do they want to surf out to the internet at the same exact time, they want to surf to the same exact website at the same exact time. Now, we only have a single IP address on the global side of our network. So we only get one public IP address here to use, but we have to get both of these devices out to the public internet and back again. So let's look at how we do that. We first record all of our inside local and outside local information. So we're recording what each packet looks like on the local side of our network. So when we put these out on the global side of the network and we change our source IP address so that it can be routed back, when we do this in the traditional way that I explained in the first part of the module, what we would do is we would change the source IP address for the packet coming from 10.0.0.10. We change that to be 198.51.100.10, and we would do the same for the packet leaving from 10.0.0.20. So both of these packets now have a source IP address of 198.51.100.10 and a source port number of 56.487. Now the source port number here for both of these messages just happenstance accidentally happened to be chosen by both workstations at the same time to be the same number. What's going to happen here is when we try to get these messages back into our network, the destination, 198.51.100.10 for both messages, and both messages have a destination port of 56.487. Well, we can't do anything with this because we don't know which message goes where. On the global side, the messages look identical, and we have no idea which computer they go back to. So when we're doing NAT like this, NAT can get confused and actually not operate correctly. So let's rewind this a little bit and apply port address translation to the traffic to make it work correctly. So now when we move these out to the global internet, we're going to treat each one separately. We'll start with the 10.0.0.10 address, and we will change that then to be 198.51.100.10 as the source address, with the source port as the same as it was before, 56.487. When we then move to the packet sourced from 10.0.0.20, what we're going to do here is we're going to change both the source IP address and the source port number. And that way, when we send this message out and it comes back now from the public internet, now we can explicitly identify each message. So when it moves to the inside of the network, we can look at the message coming from 198.51.100.10, port 56.487, see that that needs to get translated back to 10.0.0.10, change our message, and then when we look at the second message to 10.0.0.20, we'll see that it has a different source port number. We can actually do the translation properly now. When we're on a network that has multiple devices on the inside sharing one single public IP address, we need to implement this dynamic PAT, the port address translation, to make sure that all the messages that are originating on the inside that potentially have the same source port number get translated to a different source port number so that the firewall or the router or whatever NAT device we have there can easily translate between our single global socket now and our local socket for NAT. I'd like to finish this up by giving you some general NAT terms that can make your understanding of NAT much more universally applicable to firewalls. So what we've been working with this entire time throughout this entire module is source NAT, meaning that we are modifying the source IP address as the message moves from the local networks to the global networks. We're changing the source IP address and the source port number as the message moves from local to global. We can also do destination NAT or some combination. Destination NAT means that we're actually going to change the destination IP address and or port number as the message moves from local networks to global networks. Using destination NAT or a combination of source and destination NAT at the same time, these are uncommon and are used in special applications. The cases that I've seen destination NAT used most often is that when you're trying to build a VPN tunnel with a small organization and the IP space that they're using in the small organization overlaps with the IP space that they need to connect to in your organization. So you have two organizations both using 10.0.1.0/24. You have to do some type of NAT to make that work. You don't necessarily need destination NAT, but my experience has been is when you're working with a very small IT shop and you're a very big IT shop, as was the case for us at UW Hospital, we found that sometimes doing the destination NAT allowed us to solve problems much faster than what could happen if we turned it over to the very small organization that may have had only one IT person, or maybe the IT person was a consultant. So destination NAT was used in very specific circumstances to solve special problems, and we tried to use it rarely because it's a little bit more complicated to wrap your head around what's going on there.